Data is the backbone of any organization, and protecting it is crucial to ensure seamless business operations and productivity. At CTERA, we understand the significance of data security and the challenges posed by ransomware attacks. That's why we're proud to introduce CTERA Ransom Protect, an AI-based ransomware detection and protection service that allows organizations to detect, enforce, and remediate attacks in seconds. So how does it work? CTERA Edge filers monitor for any suspicious activity in real time, immediately reporting any anomalies to CTERA's global file system. If a compromised user or client device is detected, it is blocked from further access. Administrators are alerted in real time and can quickly recover the affected files and folders using the CTERA Portal Management Console. CTERA Ransom Protect can also detect ransomware attacks using decoy files called honeypots to trap hackers. With honeypots, attackers are tricked into attempting exfiltration against directories that are being actively monitored. As soon as an event is detected, CTERA will instantly disconnect that share and send an alert. With CTERA's rapid disaster recovery and continuous data protection, every version of every file is captured in an immutable, air-gapped object storage bucket. This enables IT teams to instantly roll back millions of files while ensuring minimal downtime and impact on operations. CTERA Ransom Protect helps organizations keep their data safe, their business operations running smoothly, and their users productive. Now let's see it in action. In this demonstration, we'll present two methods for detecting ransomware attacks in real time: a behavioral method based on artificial intelligence, and a second method using decoy files to trap hackers called honeypots. To get started, we have a CTERA Edge filer that's managing a dataset that is presented to users over the CIFS protocol. First, we'll demonstrate what happens under default conditions when the CTERA Ransom Protect feature is disabled. We'll transition to our user, Adam, who has a T drive mapped to the CIFS share presented by the CTERA Edge filer. This drive contains a dataset we'll use as a target for a ransomware attack. Next, we'll launch a ransomware attack simulator and target the T drive. We can witness the encryption in real time with over 2,500 files encrypted in total. To demonstrate our first method of ransomware detection, we will first recover the contents of the T drive from a CTERA snapshot, proceed to enable behavioral detection, and repeat the attack from before. We can see the contents of the T drive was successfully restored back to its original form prior to the attack. With behavioral detection turned on, we will repeat the ransomware attack and target the T drive. This time, after a few seconds, Windows reports issues accessing the share, and our ransomware simulator reports the attack has failed. Navigating back to the CTERA Edge filer's management console, we can view the incident details and obtain pertinent information about the user's identity, source IP address, and the list of files impacted by this attack. With behavioral detection, only 81 files were encrypted as opposed to over 2,500 when CTERA Ransom Protect was turned off. Our domain user, Adam, was blocked from accessing this Edge filer, and all of his active sessions were terminated. Adam's access can only be reinstated by administrators by removing him from the blocked users group. Finally, administrators of the CTERA Edge filer can view the incident details to obtain a full enumeration of the affected files and initiate a restore from a CTERA snapshot. To demonstrate our second method for detecting ransomware using honeypots, we will map another drive, identified by the letter V, to the Edge filer, containing a sample dataset. Next, we'll demonstrate an attempt to exfiltrate data from the CTERA Edge filer, a typical behavior of modern ransomware software prior to encrypting the files. Like before, we will start by demonstrating the copy is carried out successfully under the default conditions when the protection is turned off. Back to the Edge filer's management console, we will turn on honeypot detection. Turning on this feature will deploy decoy directories to the file system to assist with monitoring for data exfiltration attempts. We will repeat the data exfiltration attempt from before. Notice the local directory was cleared and the decoy directory is visible inside the V drive. Like before, we will attempt to copy the contents of the V drive to a local directory. Our copy tool failed to copy the contents of the V drive and our access to the share was terminated. As we transition back to the CTERA Edge filer, we notice another incident was logged and captured by the honeypots detection engine, along with forensic information about the user and the affected files. Finally, the user who attempted the data exfiltration was added to the blocked users group until the incident is investigated and access is reinstated by the administrators.